Find the consolidation settlement of the clay using 4 layers. In this problem, an incremental load of 200 pounds per square foot is added to a soil profile consisting of a 10-foot thick layer of sand above a 40-foot thick layer of clay. We've also been given some soil properties, and we notice the groundwater table is at the sand-clay interface. The generalized equation for consolidation settlement is the height, or thickness, of the layer times the compression index divided by 1 plus the initial void ratio, all multiplied by the logarithm of the final vertical effective stress divided by the initial vertical effective stress. Notice the overconsolidation ratio of the clay layer is 1, so the clay is normally consolidated, and we only need to know its compression index, which we've been given. We assume no consolidation settlement occurs in coarse-grained soils, such as sand, so the only consolidation will occur in the clay layer. The problem states to evaluate the consolidation in 4 layers, so we evaluate 4 equally thick 10-foot layers of clay. Rather than evaluate the settlement from 1 layer, we'll evaluate the settlement from n separate layers, where, in this case, n equals 4, 1 for each layer. The height of each layer is 10 feet, and the compression index is 0.72, but we don't yet know the initial void ratio of the clay layer, nor do we know the initial or final vertical effective stresses. Let's first solve for the initial void ratio. One way to solve this problem is to first solve for the dry unit weight, where the specific gravity of clay is 2.7. The unit weight of water is 62.4 pounds per cubic feet, and the water content is 0.37. The dry unit weight is 84.28 pounds per cubic foot. Next, we solve for the void ratio and plug in our specific gravity, the unit weight of water, and the dry unit weight. The initial void ratio of the clay is 1. Next, we solve for the vertical effective stress of the clay layer, both before and after loading. Let's first work through layer 1, which is the first of 4 layers. We'll solve for the initial vertical effective stress of layer 1 at a point in the middle of the layer, which in this case would be at 5 feet beneath the sand-clay interface. So we multiply the effective unit weight times the height for both the sand layer and the portion of the clay layer above our point of interest. The effective unit weight of the sand is 100 pounds per cubic foot, which is the same as the total unit weight since there is no pore water pressure. The depth of the sand layer is 10 feet, and the depth of the clay layer is in the middle of layer 1 is 5 feet. And we do not know the effective unit weight of the clay layer. However, when solving for the initial void ratio, in one of our intermediate steps, we determine the dry unit weight. And knowing the water content, we can solve for the total unit weight. We plug in our values, and the total unit weight of the clay layer is 115.46 pounds per cubic feet. So we subtract 115.46 minus 62.4 to get an effective unit weight of 53.1 pounds per cubic feet in the clay layer. So our initial vertical effective stress for layer 1 is 1,266 pounds per square feet. The final vertical effective stress is equal to the initial vertical effective stress plus the added load of 200 pounds per square feet, or 1,466 pounds per square feet. So we have our initial and our final effective stress values, and we can solve for our consolidation settlement for the first layer, which turns out to be 2.75 inches. Keep in mind, this is just one of 4 10-foot thick clay layers to evaluate. Layers 2, 3, and 4 can be solved in a similar fashion. The first part of the settlement equation is the same. The only difference is the initial and final stress values. The initial effective stress for layers 2, 3, and 4 can be evaluated at points 15, 25, and 35 feet beneath the sand-clay interface. At this point, it would be convenient to set up a table of values for the initial and final effective vertical stresses, where the final is equal to the initial plus the load. Returning to our consolidation settlement equation, the second layer will consolidate 1.98 inches, the third layer will consolidate 1.62 inches, and the fourth layer will consolidate 1.27 inches. Adding the settlement from all 4 layers, the settlement from consolidation is 7.62 inches. When compared to the possible solutions, the answer is D.